So far, we discussed models that are suitable when trend is not present and seasonality is not present, like naive method or moving average, weighted moving average, exponential smoothing. All of them will fail to give you accurate forecast if there is trend or if there is seasonality. So if there is trend in the data, then what do we do? Then there are several methods that can handle trend. Your textbook discusses two of them. One is exponential smoothing adjusted for trend, and then trend projections. Now I'm not going to discuss the exponential smoothing model. We'll only talk about trend projection. So we'll skip that part. The trend projection is to simply fit a straight line through the data, like a plus bx, a being the y-intercept, b being the slope, and you use time values for x. So the first time period t will be equal to 1, the second one t will be equal to 2, and so on. Then for the future, if you want to project a trend forecast, then you determine what the t value will be for that future time period and insert that t value into this prediction equation, and y hat here stands for the predicted value or the forecast. And we will be using the least squares method of regression. Here in least squares method, what we try to do is you look at the actual value. So the stars are the actual values, and the straight line is the predicted value, a plus bx. Now there will always be some amount of deviation between the actual value and the prediction equation. So this is called the prediction error or deviation. So if we take all of these deviations, square them and sum them, that is called sum of squared error. Now our objective is to find a line that will minimize that sum of squared error, least sum of squared error. So that is the reason why this is called least squares method, and when we follow this approach, we can derive the formula for a and b as follows. So y hat equal to a plus bx is what we are after, and this is the formula for b, where we have sum of x times y minus n times x bar times y bar. Then in the denominator we have sum of x squared minus n times x bar squared. So we need to find the slope coefficient first, and then you plug that slope coefficient into this equation and we find a. Once we have a and b, then we can use it for predicting future forecast. So here is a worked out example. So we have 7 years worth of data for electrical power demand. Now we use the year number as the x column, and then the demand is y column. So we have x squared, x times y, and add them up and plug it into the formula. Okay, and you get your slope coefficient and the intercept, and here is the prediction equation. And then we can use that prediction equation by plugging in the value of 8 for x for year 8, plugging in a value of 9 for x for year 9, and so on. So we will now look at a worked out example. Now let's work out the trend projection example. So we have data for years 1996 to 2002, sales data, and we want to develop a least squares trend line and then predict sales for year 2003 and 2004. So the first thing to do is to assign t value for the years. So we'll assign a value of 1 for the very first time period, 2, 3, 4, 5, 6, 7. Now we're going to use this column as the x column and this as y. Then our objective is to find an equation like that. Okay, and the formula for B is sum of xy minus n times x bar times y bar divided by sum of x squared minus n times x bar squared. So we need the sum of x and sum of y so we can compute. Alright, now let's look at the sum. So this is sum of x is 28. Okay, this is sum of y is 917. So here n is sum of x is 28, sum of y is 917, n is 7, so x bar is 28 over 7 equal to 4, and y bar is 917 over 4 equal to 131. Now we need x squared and x times y. So x squared is 1, 4, 9, 16, 25, 36, and 49. So sum of x squared is 140. And then x times y would be 100, 220, 366, 520, 695, 912, 1448, 1148. And sum of x, y is 3961. So now we can enter these into the formula. Sum of xy is 3961, n is 7, x bar is 4, y bar is 131 divided by 140 is sum of x squared minus 7 times 4 squared. So if you work this out, you get 10.4643. Okay. So, and then we find A is y bar minus b times x bar. So that is 131 minus 10.4643 times 4, and that is 89.1428. So y hat is 89.1428 plus 10.4643x. So that is our prediction equation. Now we want to find forecast. So for year 2003, T is 8. So you put that into this equation. 4643 times 8, then the forecast is 172.9. So that's forecast for year 2003. for year 2004, T is 9, so Y hat is 89.1428 plus 10.4643 times 9, and that will give you 183.3. So these are the forecasts, and this is how you'll use the trend projection equation to find trend forecast.